esteemed patrons. In the course of researching and producing our Solidosaurus re-upload, it has come to our attention that there are two new discoveries, well, new relatively, regarding animals similar to or having some bearing upon Solidosaurus, that we mentioned one of them in the re-upload, and we'll probably have to mention both if we do a redo of the episode as a whole. These are Spicomelus, described by Maidment et al. In 2021, and Jakapil, described by Riguetti et al. In 2022. Now, these animals don't actually have much connecting them, although in the course of researching this bonus episode, I found a connection. A connective connection, if you will. But they are both very fragmentary Gondwanan thyreophorans. They might both be true ankylosaurs, but time will tell. But they both have some weirdness to them that I want to get into. As usual, I don't know how much actual educational takeaway is going to come from this. Consider it like a rough draft of what we'll actually say about these animals in a proper Solidosaurus video. So, Spicomelus. This is just one bone, technically two bones fused together. It's an isolated rib fragment from the mid-Jurassic of Morocco, and it's kind of remarkable, completely unique among vertebrates actually, that the osteoderms of the animal have fused to the top of the rib. And the way they figured that out is actually pretty clever. They had to do histology. They had to study the tissue of the bone to figure out, okay, the upper portion of this has the characteristics of an osteoderm, and the lower portion of this has the characteristics of a rib, and there's this fibrous bone in between them, which indicates that they fuse together. Now, that's exceptional because no other tetrapod, no other vertebrate has osteoderms that have fused to the bone like that. I said osteoderms, plural, but it's kind of just one. It's hard to tell. So in some ankylosaurs, like we saw in Euoplocephalus, you'll have osteoderms that will fuse together at their edges. That's how you get those neck rings. But this is even further than that. The osteoderm or osteoderms form one continuous bar or strap with four conical spikes poking out of it. So whatever differentiation there was between them originally when they grew, and I feel like there must have been, is completely gone now. It's just one continuous thing. Possibly owing to the fact that it was fused to the rib. And mind you, this is different from the intercostal plates that occur in some thyreophorans. We have evidence of them in Solidosaurus. They've been reported in Nodosaurus and Huayangosaurus. The intercostal plate is a bony structure that attaches to the trailing edge of the ribs, and I'm not actually sure what it does. It seems to be involved in the structure of the rib cage, or maybe it's used in breathing, but those bones originate with the musculoskeletal system. They don't originate in the skin, which is what an osteoderm is. It's a skin bone, literally. So the intercostal plates are not helpful to us here, despite the fact that they are bones fused to rib in the technical sense. So given that this animal is so fragmentary, how did they figure out that it's a thyreophoran, much less an ankylosaur? Well, partially it's process of elimination. They considered whether it might be an osteichthyon fish, but these are terrestrial sediments, and it's a pretty big animal, so either there was a fish the size of a small car really far inland, or it's not a fish. They considered whether it could be a different armored saurian, like maybe a phytosaur or a ichthyosaur, but those both died out in the Triassic, and this is mid-Jurassic. Similarly, titanosaurs show osteoderms that are actually, at the microscopic level, pretty remarkably similar to ankylosaur osteoderms, which we'll get to in a minute, but titanosaurs hadn't evolved yet by the mid-Jurassic. It could possibly be a turtle, but turtle osteoderms, which do happen, are smaller than this and have a different texture, and the fusion of osteoderms to the ribs is not something we see in any turtle. The turtle's shell is actually just its skeleton. And the shape of the rib is not consistent with a turtle. The rib is pretty remarkable. It's a very clear T shape. When you look at it in cross-section, there's a horizontal part at the top and then a vertical strut extending down. And that shape of a rib only shows up in thyreophorans. So that's Thyreophora. How did they get ankylosaur? That was done via tissue analysis by looking at the histology of the bone under a microscope. They found that at the base of the osteoderm, binding it to the rib actually, is this very distinctive woven texture of fibers. They use the word plywood-like repeatedly, which I think is illustrative, but that particular arrangement of fibers only shows up in ankylosaurs, and a very similar texture shows up in titanosaurs, like Saltosaurus. But again, it couldn't be a titanosaur, they hadn't evolved yet. There's a caveat here. The only stegosaur whose osteoderms have had histology done to them is Stegosaurus itself. So we only have one sample on that side of the thyreophoran family tree. Workers did look at the histology of Solidosaurus's armor, and both Stegosaurus and Solidosaurus show fibers around the osteoderm. That's just part of how these osteoderms grow, is that they have to have this fibrous tissue, but it's not that specific plywood-like arrangement. This is kind of cool, because it was proposed a while ago that you could maybe use histology for systematics, for placing an animal within the dinosaur family tree, but as far as I know, nobody's actually had to resort to it before now. Whereas now it's like, well, all we have is this bone, we have to use every line of evidence we have, and the histology actually lets us place, okay, it's an ankylosaur. The reason I'm talking about it at all is because there was a lot of press at the time that it was described saying, wow, this specific toy is real, because people extrapolated from this rib with 4 conical spikes on it. Well, the whole animal must have had conical spikes all over it. I'm reluctant about this. Like, we've talked before, especially in Iguanodon, about how, like, if you have one bone, you really shouldn't be extrapolating an entire animal off of that. And, like, we are a lot better at paleontology now than we were when we were describing Iguanodon, but, like, I'm seeing some similar mistakes here. Like, we don't know that the armor on one part of an ankylosaur looks like the armor on another part of the ankylosaur. Like, on the dorsal area of the body, yeah, armor tends to form these like bands, but then once you get to the sacrum, it could be something completely different. We don't know what the neck looks like. We really don't know what the tail looks like. If this is a Gondwanan ankylosaur, which are called parankylosaurs now, which is not a great name, but anyway, if it's similar to like Kumbarosaurus or Antarctopelta, it could have a really weird tail. Antarctopelta has that like tail frond of spikes. It's really cool. But yeah, I can't say that the restoration where it looks like this is wrong, but like that's not the only possible way that you could restore it either. So like, just pump the brakes a little is what I would say to that. We don't actually know what Spicomelis's phylogenetic placement would be. They did not do a phylogenetic analysis, probably because they would only have like 4 characters that they could encode. But I'm excited to see where this goes. Clearly, ankylosaurs are more diverse morphologically than we appreciated. Incidentally, this is the earliest known ankylosaur since it's from the mid-Jurassic, and it's been thought, you know, the classical idea of ankylosaurs was that stegosaurs died out and ankylosaurs kind of stepped into their niche as the armored dinosaurs. But evidence from Western Europe, from the Morrison Formation in America, and now from North Africa is showing that no, ankylosaurs and stegosaurs coexisted for tens of millions of years. Spicomelis existed alongside an animal called Adraticlete, which is known from a lavish 6 whole bones, but it seems to have been similar to like Miragaia. But our understanding of the stegosaur die-off is not great. like, it's been correlated to the rise of angiosperms, it's been correlated to the decline of cycadophytes, it's been correlated to the rise of ankylosaurs, like we just said. But Thyreophora as a whole in the late Jurassic, early Cretaceous is not as complete of a picture as we would maybe want. And let's throw into this mix a very weird little animal from the earliest late Cretaceous of Argentina called Jakapil. This is a little armored, emphasis on little, it's like 1.5 meters long, although it is a juvenile. Thyreophoran, possibly true ankylosaur from the Candelaros Formation. It's from the same formation as Giganotosaurus, but it's from the locality that's right on the edge of the Paleo Desert. And the authors noted that, like, it's weird, we've been prospecting in this desert for like 20 years. This is the first we've found of this little animal, and they think that it's because Jakapil didn't actually go into the heart of the desert. They found this specimen along what would have been the edge. But again, this is a pretty fragmentary specimen. We have multiple bones, or at least parts of multiple bones, and most of a jaw, most of a shoulder, and like 40-ish osteoderms. And what's striking about it is that the jaw looks like a Neoceratopsid jaw. It's like you took a Udanoceratops or something and just took the jawbone off of that and put it onto a Solidosaurus or a Scutellosaurus. It's very odd. And you might be tempted to think, like, well, is it a chimera? And no, it was found disarticulated, but if this was a chimera, we would expect to, like, find 2 left femurs or something like that. And there's no evidence that there's more than one individual represented in the sample. Also, all the elements fit together to the extent that they can with such a fragmentary specimen. But it makes it very difficult to actually place it systematically. They managed, but Maidment actually had some criticisms of it, which we will get to. But first, how did they know that this is a juvenile specimen? Well, partially it's high-level skeletal stuff looking at fused versus unfused bones, but also they did histology to a couple of ribs and a couple of osteoderms. And they found 7 lines of arrested growth in the rib, which is where the growth of the animal seasonally slowed down because it was winter and there was less nutrients available. They think that means it's a 7-year-old animal, whereas in an adult thyreophoran we would find like 8 to 13 lines of arrested growth. Also, the lines are not decreasing in spacing, so its growth hadn't slowed down yet, and there's no what's called an external fundamental system, which is where the lines get very closely spaced, and it shows you that the animal has reached adult size. So they think it was not a juvenile anymore, but either subadult or young adult. There's also little to no bone remodeling going on, but the amount of denticles on the teeth, the ridges on the leg bones, and the presence of osteoderms behind the head all indicate that this is not a juvenile animal. I didn't realize this. In ankylosaurs, finding post-cervical, so not on the head or neck, finding osteoderms on the body or the tail is an indication that the animal has reached maturity. Those osteoderms grow in after the ones on the head and neck, and that's borne out in the histology of the osteoderms that they sampled. Though obviously, because the specimen is disarticulated, they don't actually know where those osteoderms were on the animal. They have guesses, and you can see restorations of the animal with where the conical spines are on the head and neck, and then the more plate-like osteoderms are spread out across the body, which is reasonable. Like I said, the jaw is weird. They say that the predentary, the bone at the front of the jaw that supports the beak, resembles Lizothosaurus. It resembles the plesiomorphic condition. And like, yeah, schematically it does, but it's huge. It resembles nothing so much as a Neoceratopsid predentary, where it's got this long strut extending from the bottom. And like we talk about in the Solidosaurus re-upload, a predentary might not have even been bony in basal thyreophorans. Anyway, when they fit the dentary into that predentary, they find that the angle it forms is actually pretty shallow, which implies that the back of the skull was pretty narrow, because if the jaw has to fit into the skull, we would assume that they're similar in dimension. Material from the upper part of the skull is fragmentary. It appears to be similar to Solidosaurus, and other characteristics are similar to Kunbarasaurus. They didn't assess those characters ontogenetically. Like, we established that this animal is subadult, and it's not clear to me whether, like, brain case characters looking like basal thyreophoran might be ontogenetic variation. I would assume that those would reach their final form fairly early in the animal's life, but I'm not sure about that. When they did phylogenetic analysis, they did attempt to control for ontogeny by, like, selectively excluding characters, so I guess I shouldn't second guess them on this. The other weird thing about the jaw is that the posterior portion, the back of the jaw, is really deep. It's got this crest on the ventral side of it, on the chin side. And either that is a place for muscles to attach, but they think maybe not. There's a crest that might be attaching the pterygoid muscles on the medial surface, in which case the ventral crest is actually just display, probably. And I noticed that in the original press release for this, they included a restoration where in between those chin crests, there's like a filamentous, feathery beard. And a lot of people have just been like, yeah, that looks cool. And so most of the art that you see of Jakapil now also has the beard, and I appreciate this. It's like a little billy goat dinosaur, though with dermal armor. The dermal armor, I mentioned that it varies in shape, but it is kind of peculiar in that it resembles more derived ankylosaur armor, where it's large plates with relatively shallow keels. It doesn't really look like a Solidosaurus armor, even though phylogenetically this animal is placed fairly close to Solidosaurus. Though there are a couple of osteoderms that are fused edge to edge, which does happen in Solidosaurus, though it also happens in, like, Pinacosaurus and other derived anks. Phylogenetics they did indeed. They applied the dataset from the Stegouros paper, which had just occurred to me. Earlier I was saying that Antarctopelta was the animal with the frond-like tail club. That's not, like, Antarctopelta probably had that, but it's Stegouros was the animal that was found with that tail club. They're closely related anyway, so, like, if Stegouros had that, and it did, it stands to reason that Antarctopelta, which is a close relative, would have had a similar arrangement, but sorry, I misspoke. Anyway, it's going to be important in a minute that the data set that they primarily used included some ceratopsids, including, like, basal ceratopsids and neoceratopsids. But what they noticed, they noticed this in the data set they put in the primary paper, and then in the supplement they ran a bunch of other data sets, although all of those were specific to Thyreophora. They noticed every time they put Jakapil in, it lowers support for a bunch of clades. And, like, yeah, you think? It's an animal that has this constellation of features that you see in basal and derived animals, and it's pretty fragmentary, and it's not ontogenetically mature. Like, of course it's going to mess up your trees. But one quirk is that they used the data set from Norman's redescription of Solidosaurus, and it actually pulled apart his idea, where Solidosaurus is actually like a stem ankylosaur. Properly, we shouldn't call them stem ankylosaurs, because Ankylosauria isn't a crown group, but I don't know what else to call them. But then, when they ran it with a different data set, they did recover essentially that topology. So Jakapil doesn't care. Jakapil will reverse your hypothesis no matter which one it is, whether it's orthodoxy or not. We saw a situation like this in the Ornithosceletocene episode with, like, Dromameron, where there are some taxa that if you put them in your analysis, they're just going to start pulling apart trees. That's just what they do, because phylogenetic analysis wants to place an animal most parsimoniously, and sometimes the most parsimonious placement is splitting the difference, putting it in a very basal location, even if that creates a long ghost lineage. And this does, because, like I said, this is from the Cenomanian, this is from the Candeleros Formation. So if, as the authors suppose, this is either a basal thyreophoran or a basal ankylosauroid? Is that a clade? Anyway, it would have to be descended from thyreophorans that were already in South America before it split off from Pangaea, and that's exactly what they suppose, that it's a homegrown ankylosaur of some kind. Well, not entirely ghost. They do connect the dots with some isolated osteoderms that we found in the Bajada Colorado Formation, which is early Cretaceous. It's the rock that Bajadasaurus is from, hence the name. And we also have some indeterminate ankylosaur osteoderms from the Campanian, so later on in the Cretaceous of Patagonia. And I wonder if they're right about Jakapil's placement, finding isolated osteoderms in South America might not necessarily mean that it's a traditional quadrupedal giant ankylosaur. It might be something more like Jakapil. This is weirdly similar. There's an animal from Australia that is known exclusively from an ulna that the original describers consider a ceratopsid, but other people have looked at it and said, no, this is an ankylosaur ulna. So it's like, I guess it's actually the reverse of that situation, where the actual describers are saying this is probably an ankylosaur, but then other people come in like, this has some ceratopsid stuff going on. But speaking of forelimb elements, Jakapil preserves a decent amount of the arms, and it reinforces the idea that we've talked about where basal thyreophorans were retaining at least facultative bipedality and bipedalism. There we go. The weird part is that the manus is weirdly robust for an animal with such short arms. Like it couldn't have been walking on those arms. They're so short compared to the femur. And we don't have the complete femur, but you can extrapolate the length of the femur pretty accurately based on the diameter. Also, the thigh bone is shaped like you would expect a biped's thigh bone to be shaped. At least the part we have is. Anyway, I keep saying if with regards to this animal's placement. That's because on Twitter, Maidment had some things to say about the systematics in the paper. She pointed out that if all we had was the jawbone and the vertebrae and the shoulder, which are our best preserved elements anyway, you'd probably place this as a marginocephalian or probably a neoceratopsid. There's this element at the top of the back of the jaw called the coronoid eminence, which in neoceratopsids it's really big, but in Jakapil it's broken off, and we don't know that it would have been small but still prominent, or if it was really big, like in a marginocephalian. Like I said earlier, the predentary is very ceratopsid-like. The teeth are, in Maidment's words, unlike any other animal. They're maybe pachycephalosaur-like. They're just odd teeth, and I'm not great at distinguishing tooth features, so I'm not going to weigh in on this, but it is remarkable that the top and the bottom teeth are so different from one another. But like I said, the animal has this extremely unusual jaw, so maybe the teeth being different isn't that surprising. But Maidment also pointed out that the post-cranial remains are so fragmentary that there's not a lot of information you can actually extract with them, which I vibe with. That's what I had to say about Spicomelus, which was Maidment's paper after all. Anyway, there is a line of evidence in the post-cranial remains that Maidment didn't comment on, at least not that I saw, and we'll get to that in a second. But to review, it seems that the options for Jakapil are either a weird basal thyreophoran with a really big jaw that is a descendant of a homegrown lineage of Argentine thyreophorans, possibly true ankylosaurs, or it's some kind of marginocephalian, possibly a neoceratopsid, in which case it's an immigrant. It's a more recent arrival to South America. Is that possible? I mean, maybe. The radiation of ceratopsids is not very well understood, but it seems that after originating in East Asia, they made their way across the globe, either across Beringia to Western North America, or across Europe to Eastern North America, or both. So making that next step, like they were in North America by the late Aptian and definitely by the Albian. So making it all the way down to South America by the Cenomanian isn't that unreasonable, though North and South America were definitely pulling apart at exactly this moment, and the tectonics of the Caribbean, so that whatever island hopping ceratopsids would have had to make to get to South America is poorly understood. Also, sea levels were going up and down in this period, so maybe there were land bridges opening up and closing again relatively quickly, geologically speaking. But it would be a really fast dispersal in geologic terms, so that's a criticism. Proposing that these animals have a marginocephalian affinity does run into the problem that the dermal armor is completely unprecedented in ceratopsids or pachycephalosaurids, or at least postcranial dermal armor. Again, it's not impossible though. Like, titanosaurids developed osteoderms, and those osteoderms are strikingly similar to ankylosaur osteoderms, despite these two groups of animals being pretty distantly related. More distantly related than marginocephalians are with thyreophorans. And both Maidment's Spicomelis paper and the supplement to the Jakapil paper note that that plywood-like, although the Jakapil supplement doesn't use the term plywood-like, the woven texture of the fibers around the osteoderms are noticeably similar to ankylosaurs and to titanosaurs' osteoderms. This is because the osteoderms are originating in the same layer of the dermis. It's just an inherent property of how they develop. So it's parallel, even though it doesn't represent a close phylogenetic affinity. But since Jakapil preserves those crisscrossed plywood-like fibrolamellar structures and compares them to the same types of fibers that the Spicomelis paper compares them to, and I noticed that in cross-section, the rib that they sectioned of Jakapil has, it's not as pronounced as in Spicomelis, but it's definitely clearly a T-shaped cross-section. If we can use those two things, if we can use the plywood-like fibers and the T-shaped cross-section to do systematics to the specimen, to place it in Ankylosauria, or at least in Thyreophora, shouldn't we be able to apply what we did for Spicomelis to Jakapil? Maybe. And maybe is kind of the takeaway from this. These are active areas of research, very new, very exciting stuff, but hard to say anything for sure yet. I really hope somebody comes along and tests Jakapil in more phylogenetic frameworks that include non-thyreophorans, like more data sets that include ceratopsids or ornithopods or other basal. Well, we have a pretty good sample of basal ornithischians at least. But yeah, I'm excited to see where it goes, and I hope somebody does more on this before we do a redo of Solidosaurus so that I can say more intelligent things about it than, well, isn't that weird? But I want to thank you guys for tuning in for this bonus episode. I want to thank you so much for your continued support on Patreon, and I'll see y'all next time.